What is it for today? Today's date is my journal update. Is literally the most important thing today is get this moved out. So let me get a drink first. Let me get this done. Today's video is cybernetics. Yeah. Very important. So N for November, S for Sierra, I for Indigo, G for Gold, I for India, I for India. It's a human rights protocol. And today's date is the 16th of March 2026. But to the Trident, um, basically, the video today is what I call the tripolar symmetric interpreter, Trident interpreter. Keywords, Trident interpreter. So, the Trident interpreter is a consensus system that responds to ensure the position via some kind of probably some kind of a state, some kind of probe. Now, a probe is something that answers a question. A system that can question itself, and that's why it fits into the step-by-step framework. So it's a feedback loop system via a model of a system. Isn't the sensor or not? Let me give you two examples. So you're gonna have a sensor probe via a thermodynamic scale, a thermometer via thermodynamics, the force vectors. Now, there are two. This is a very bad example, but there are two Fahrenheit equal to 0 newtons of force. If you have a motion, if you can, force equals to mass acceleration, and that must mean there's some equivalent. Whether there is mass and acceleration, movement, magnitude and direction, which is basically a vector, vector components. The system of feedback loop via thermodynamic scale, where 32 Fahrenheit equals to 0 newtons. When you move move the scale needle up, you can get a thermodynamic scale that that ensures a biological sensitivity for something called fine. So if you have a if you have a exoskeleton, something that needs to enhance you, double your or triple your double your power, double your force. If you add a force, if you have a force of say one if you put a force of 15 newtons, if you put a force of 15 newtons to some system, and displace it, force equals displacement equals so vector displacement mass is found mass is found mass is found. Basically, I'm trying to find out displacement displacement in distance. The displacement the shortest path between the starting point and the end point along the direction. Imagine you're taking a winding path through a park, 3 meters, 6 meters. Okay, displays the vector because it has both a magnitude and a direction. But this is displacement quality. So basically, displays the distance. The short distance between 2 points. That's between A and B. It's a type of distance, and you get a scalar and vector quality of a system. The speed equals to the time, and delta means change in. So the change in basically displacement. So if you have a thermodynamic scale, uh, um, let me try to find out how to calculate displacement. Um, so So it's a short straight path between 2 points. So 3 is equal to 5 position minus initial position. 10 minus 2 is 8. So velocity times time. Um, uh, so, for example, the displacement is called velocity of 5 meters per second. Uh, you have the time per second. You have 5 times 4. Uh, what is 20 meters? If the motion is not a straight curved path, you have to apply the magnitude. Hold on, we'll start again. Uh, So I'm looking here. So basically the magnitude and the direction. So the magnitude is basically the space is basically magnitude, the square root of x1 minus x2 uh, plus plus y1, y2 minus y1 squared, but the indices are 1 and 2 based on the components of the scale 3D, 4D, 5D, square root of all those systems. So let me try to calculate it properly. So I'm telling you guys, this system expressing the distance via step is resource. But the system has to be literally cybernetics bound because it has a feedback loop, and that's where the probe comes up. So let me try to do some paper here. So let's say you have distance, uh, a distance, velocity, velocity, displacement. If velocity is constant, velocity displacement equals velocity times time. But if you have displacement, it's 5 position minus initial position. So if you start at 2 meters and you end at 10 meters, displacement is 8 meters. Direction matters if you end up when you started, so it becomes negative. So you have a negative velocity, so you have an opposite vector or straight motion. So, I'm just to find it here, distance here, a measurement of how far through space. So you have a model of now this is scalar vectors. I don't even know. So this is basically a introduction to the system. Um, uh, so if I do the proposal vector, what am I saying here? Yeah. So one more model in here. Basically, I'm still talking here. So let me try to get on the paper. So you have 3 to 2 distribution of system. So the graph is retrievable. Definitely. So you have displacements of so if you have to start at 8 meters and you're going to 10 meters, it's just displacement. But in 3D, you have to have an something gives an angular displacement model. So the angular will be displacement based on the shortest angle you have to rotate to secant or y cosine theta, and then the displacement factor will be the angle. So basically, if you have the shoulder part, you're gonna have angle system, but angular thermodynamic scale. So just in temperature, 32 Fahrenheit, 32 Fahrenheit will be some temperature, but that temperature equal to 0 newtons, equal to 0 newtons force. To zero. That must mean that there is some other equivalent in the system that can give you an angular, basically, it was kind of angular momentum. So angular momentum. So force equals to how to calculate angular momentum. So movement at an angle, basically. Angular momentum tells you how much rotation a motion has. So classical angular momentum is L equal to L. L is angular momentum. R vector. R is a vector that pivots. Where P is a real vector, is a momentum vector. M times V momentum. Where is movement or displacement? X is a cross product from your tab. From a tab. So the cross product is here. So from a tab here, around. So you have point the index finger along the arm, so this arm here, middle finger up. So let me show you guys this. So this is saying so the particle momentum is L times angular momentum, with basically the position of the pivot. Now MV is momentum of the cross product on the top. Now this cross product is the given momentum R is distance some the pivot. This radius A here. P. Oh, R. No, this is B's R. And this is exactly the same structure covered up on the page. Yep. So R for the pivots, P for the momentum. This is P, and theta for the angle between R and P. So rigid body. So R like a wheel. This one's really like a wheel. So this is a R momentum times sine theta. So the magnitude is here. Moving for the magnitude basically for the scale model. So mass, position, velocity, or calculate algorithm for you. So the mass, okay. So let's use the mass of the object is okay. So I am trying to model a dynamic scale such that the 2 Fahrenheit equals to 0 newtons. Newtons of force in an electrodynamic system such that so given such that a dynamic scale piecewise functor um, ensures a regulation via a cybernetic feedback loop. The 2 Fahrenheit 0 newtons of force is a vector with zero momentum with absolute momentum of zero. Using the momentum law, I'm trying to map map out boiling points into a dynamic scales from 0 force to the 2 Fahrenheit to 100 degrees Celsius Celsius in degrees and Celsius. Let's see what this is. It will not be able to do this on the show. So let S be a dynamic scale fraction. This is the 2 force. No, Fahrenheit. This is where Celsius minus 32. Yep, the Celsius. F of S. This one is 32. 32 is then North Pole's baseline. Yeah. ST. So the boiling point of water combined with 2 S2. So this is the model here. So this heat is measured in joules. The more instance in kilograms. So don't change. Time equals work divided by power. Yeah. So now use work divided by power. Work done in time to ensure basically, I'm saying you have two formulas. This is the reference because time power relationship. So okay, basically it's not down, but so basically the future. Because if the future look at some prediction, so my goal so second part of the video was literally the interpretation. You gotta have take some state and data. We can have data for the state. So you have here and now, there and then, and when the web. These are three valid states. We have three valid errors from the previous state. Actually, we want to reduce this problem to 3 to 1. Namdi. So you're gonna have a symbolic interpreter that has two void pointers that map onto the set of root spaces, and so basically determine how two void pointers. You're gonna have three void pointers. That's to the map to probe now. So like you have three Lexas, three systems, with Alexa, and that system has Alexa, Parser, and ESD, and the result because there is a probe. Now, if you have three entities, three I love you, if you have three tridents, three nodes, I, me, myself, and I, part of one network. Me says I love you, and then myself says you love me. The two pointers, you and you, are pointers to the same data, but they share the same alias pointers. So you is one pointer on system, and I is one pointer. So I love you, me myself. So I love you, you love me, and then result as who loves who in the third state. See that who loves who, basically I, me myself, and I. So this is an I pointer, three pointers that determine a system state, but they are homogeneous because they map onto the system, and there's also called interpretation system. What's symbolic interpreter? So I'm going to do symbolic interpreter probing. So system has some feedback loop via the probe of the state and transition. So it kind of telemetry. So it simply always verifies as a valid state. So an error state that's always meaningful. So the is sort of meaningless execution hold And the only thing you understand now is it creates, destroy, destroy, and break three different things. So you're gonna have this one here basically. So you have here, right here now, there and here and now, there and then and whenever. We're gonna have the three tridents. We're gonna have here, we're gonna have create, destroy, going to show a process which is called so you call a bootstrapping procedure. You can have a system bootstrap it's firmer. The interface is sticky, 30% job. So you have create, destroy, build and break, build and break. So the bind and also binding be the two. So you can reverse something. You can reverse a rollback system. So if you want to reverse something, so this basically yesterday's work. In secret firmware, with the Muko boot sequence, boot in a latitudinal order, a Kubernetes interface that loaded when needed, when needed, hungry. So basically, they are sensory rights that the secret firmware creates, the system loads, the load components, which are those C# files. I'm not C# by the way today, but I'm going to learn to program C# and build a UI interface in C#, basically. But the referral of the system is the human suffering via the probe, and so it encodes the probe and the product Trident part, which are three deployable graph. The Muko boot tripartite is consensus firmware, and module drift. Drift is basically defined in the next page. Drift is defined as a three-way or tripolar three-way bipartite colorable graph that shows so G equals UVW, where U is the user, V is institution, and W is the third party graph. These three graphs interact with each other, may interact with each other or not, but when interact with them, they have the result colorability. So who gets to color what? Who's in the wrong, basically? Who's in the wrong? And who's in the right? Which is what indicting means of the graph. Graph induction is a problem, but the problem is the solution space of the graph. So you have the work at this is you can have T equals change in T equals B squared minus 4AC, where Y where Y equals 1. So basically the graph has B squared minus 4AC, which are the components of the graph. You're gonna have discriminant B squared minus 4AC, the graph, which is the void divided with the ratio of the graph. Isomorphism. So the graph does know what you do. I'm going to write all this myself via the boot sector. Now the boot sector is the firmware interface, and that is in C#. So you can open the file. So you're gonna have the bipartite column, the green and yellow, green and orange, yellow and orange, and red and orange. But the state orange is a state. There's nothing there. But you're gonna have a signal. So you're gonna have four signals. You're gonna have a signal of signal, no signal. Signal means you get a signal. No signal means you don't get a signal. So you have four. You're gonna have four kinds of signal. You have signal, this will get appear here in analogy. Probably we're gonna have signal, no signal, noise, no noise. And this number usually shows this application of open system resolves amongst the boost sectors. So my goal is first to learn assembly to resolve this issue, all the big problem. So basically, I have to learn uh, assembly to learn to write the boot sector, write the boot sector via stability solution lab. I try to put it. The system is complete when it has because I'm complete. It's tripolar. It's complete because there's a yes, no, and maybe consensus. And if there's this is supposed to report something, the Alexa and the Parser report something, and there's also something to report via the telemetry hashing. So this is a probe here. P is a probe as a question. So it can be who 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 has the state who who the three receipts you can have 3 to 2 receipts, 3 concession receipts, but 2 concession outputs. So you can have yes and no. So this is 2 to 1 market for the receipts. So the receipts are defined by the drift of the message to the parcel, the drift of the parcel next down, and drift of the next down and the parcel. And that's what I'm saying. It's a model that way. Because there's three parties. So, this for this to graph G equal to VC, VT minus TT, equals to but the error handling or the telemetry error is basically conceptual, so it has to hold something via the probe system. So I'm learning C sharp and C++ and assembly to do this on the right one system, but it's a boost system, right? That's elementary. So the drift is defined. Drift is Trident ruling. The ruling for the pro external T given S given T given a process given S or some state that implies T D the ruling of some T time from state business qualifier to determine when someone's ghosting you. If someone's leaving you or someone's not being someone, but new firm says those to sue something, some people. So I'm happy with it. So basically, goes to investigate. What is this? It goes to mitigate some the solution spaces and spread it out over the calculus. Basically, these poles represent vector quantities. These are vectors here. These are called auxiliary vectors. So these are auxiliary vector components. Auxiliary vector that determine a system state based on what has also been observed. But that's the beauty of the system. So thank you guys for watching. Let's continue this video. Anything else? No.